In today's lesson, we will focus on one-sided limits in calculus. We will understand the difference between left and right approaches. Welcome back to my channel, Numerics with Nadia, and let's dive into our lesson objectives for today. By the end of this lesson, you guys should be able to define a one-sided limit, distinguish between left hand and right hand limits, identify when a limit does or does not exist using one-sided limits, and last but not least, we will evaluate simple one-sided limits from graphs and equations. To start off our lesson, let's get into our key definitions for today. First off, what is a one-sided limit? A one-sided limit is a limit where the function is approached from only one direction, left or right. Next, we have a left-handed limit. The definition of a left-handed limit would be where the value of f of x, or our function, approaches as x approaches a from the left. A right-handed limit is where the value of f of x approaches as x approaches a from the right, and the limit does not exist, or shorthand we say DNE. This happens when the left and right-handed limits are not equal or are unbounded. Now to quickly get into the notation, in order to write a limit from the left, we would write limit as x approaches a from the left, so that minus sign of f of x. And to write a limit from the right, we say limit as x approaches a with a plus sign of f of x. So think left minus and plus right. So now that we've gone through these definitions, let's get into some examples with diagrams. Our first example today is going to be an absolute value function. So the function we have here is the absolute value of x over x. So we're going to look here at the limit as x approaches 0 from the left of our function. When we approach it from the left, we see that the value at that point would be -1. So the limit as x approaches 0 from the left of f of x is -1. Now let's do the limit as x approaches 0 from the right. When we do this, we see that the limit as x approaches 0 from the right is +1. So looking here, our left and right limit do not match. So the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x. Because of this, we know that the limit does not exist, so you can either write does not exist or DNE as your answer here. So that wraps up our first example. This was an absolute value example. The key for all of these is to try to graph it first. The next example we have is going to be a graph with a hole. Our function here is x squared minus 1 divided by x minus 1. So before we dive into any limits here, let's first simplify our function. We know that x squared minus 1 is the same as the difference of two perfect squares. So that would break out into x plus 1 and x minus 1. When we do that, we see that we have x minus 1 terms on both the top and the bottom, so we can cancel those out. And when we do that, we get that f of x equals x plus 1, where x cannot equal 1. And now we can start and find the limit. So let's try to find the limit as x approaches 1 from the left of f of x. So when we do that, let's first locate the 1. When we approach 1 from the left of our function here, we end up getting a value of 2. And let's just do the same thing from the right. So the limit as x approaches 1 from the right of f of x, we'll do the same thing. As it approaches 1 from the right, we also get 2. So since the left and right hand limit match, we know that the limit does exist here. Even though the graph has a hole, it does exist here, and the limit would just be 2. So writing out the answer for this one, the limit as x approaches 1 of f of x would just be 2. And now let's move on to our third and final practice example for today. For this one, we have a piecewise function. And a piecewise function is just a function whose domain is partitioned into different intervals. In our case here, we have 2. So it says that f of x equals 2 if x is less than 1, and f of x equals 4 if x is greater than or equal to 1. So we can see that on our graph here. Now let's go through and start to find the limit. So let's find the limit as x approaches 1 from the left. When we do that, once we label our 1, we see that as we approach from the left, the limit as x approaches 1 gives us a value of 2. And then we will do the same thing from the right. So the limit as x approaches 1 from the right, we will be following that blue line. As we approach from the right, we see that the value of our function is 4. So the limit as x approaches 1 from the right would give us a value of 4. So now looking at these two, we see that the limit as x approaches 1 from the left and the limit as x approaches 1 from the right, they are not equal to each other. And what does that mean? If the left and right limit are not equal, that means that the limit does not exist. So our answer for this piecewise function example would just be that the limit does not exist. That is our last example for our lesson today. Thank you guys so much for watching. I hope you enjoyed the video. Please like it if you did, subscribe if you haven't already, share this video with a friend, and I will see you guys next time.